Exercise 3.8. Show that r minus 1 divided by r plus 1 times r plus 2 times r plus 3 is equal to negative 1 over r plus 1 plus 3 over r plus 2 minus 2 over r plus 3. And that's fairly easy to do just using our partial fractions decomposition theorem. So we start out by assuming that r minus 1 is equal to r minus 1 divided by this thing is equal to a divided by r plus 1 plus b divided by r plus 2 plus c divided by r plus 3, and then multiply both sides by r plus 1 times r plus 2 times r plus 3. And so that gives us that r minus 1 is equal to a times r plus 2 times r plus 3 plus b times r plus 1 times r plus 3 plus c times r plus 1 times r plus 2. And then we just take particular values of r. So if we take r equals, say, negative 1, if we want to find r, so negative 1, that will give us that negative 2 is equal to 2 plus negative 1, so 1 times 3, nope, 2. So a times 2, and then from there we get that a is equal to negative 1. And then we'll do the same thing for b, but this time to find b we select r equals negative 2, because then that will knock everything else out. And if we take r equals negative 2, we get that negative 3 is equal to b times, what is it, negative 1 times 1. So just negative 1. Okay, and so that tells us that b is equal to 3. And then finally we do the same thing for c, except this time we take r equals negative 3. So if we take r equals negative 3, we get negative 4 is equal to, so that will be negative, so c times negative 2 times negative 1. Okay, and so that would mean that c is equal to negative 2. Okay, and so we see that we have exactly what we're supposed to have, because a equals negative 1, b equals 3, and c equals negative 2. So we have proven the first part. And now for the second part. We want to use the method of differences here. Now just looking at this thing, negative 1 over r plus 1 plus 3 over r plus 2 minus 2 over r plus 3, it doesn't look but like we can directly use it here. But then you stare at it for a little while and you see a little trick. Okay, so if you haven't seen the trick already, pause it and see if you can find it. So this is equal to the sum from r equals 1 to n of negative 1 divided by r plus 1. And then we can actually split this thing up in the middle. So plus 1 divided by r plus 2. And then, well, plus 2 divided by r plus 2. And then minus 2 divided by r plus 3. And that is extremely convenient because now we can write it in this form. So this is equal to negative of the sum from r equals 1 to n of 1 divided by r plus 1 and then minus 1 divided by r plus 2. So negative of that sum and then plus 2 times the sum from r equals 1 to n of 1 divided by r plus 2 minus 1 divided by r plus 3. And then we can use the method of differences immediately. In this situation here, our function is clearly f of r equals 1 divided by r plus 1. And so this thing is equal to f of 1 minus f of n plus 1. And then including the negative, the whole thing becomes so f of n plus 1 minus f of 1, which is 1 divided by n plus 3, and then minus f of 1, so 1 divided by 2. Okay, on to the next part. Alright, so this one clearly has a function f of n, well, I guess we usually write f of r. F of r is equal to 1 divided by r plus 2, and so this is equal to f of 1 minus f of n plus 1. And then multiplying it by 2, it's going to be 2 times 1 divided by n plus 3, so 2 over n plus 3, and then, wait, what am I doing? Because I did f of n plus 1 first over here, I got caught in the trap. But it's okay, because we can just make it a negative. So minus f of n plus 1 plus 2 times f of 1, so 2 divided by 1 plus 2, so 2 divided by 3. And it's time to add these things together, and I see I made a mistake here. I made it n plus 3. n plus 1 is n plus 2, so that should have been n plus 2. My mistake. And then combining everything, we have 2/3 minus 1/2. So that would be 4 over 6 minus 3 over 6, so that would be 1 over 6. And then it's plus 1 over n plus 2, and then minus 2 over n plus 3. And if you like, you can simplify it into a single fraction.